Alright, so today we're going to get started with Unit 1, which is all about matter. And today we're going to start the first section, which involves types of matter as well as states of matter. Okay, so we all know that matter is made up of atoms, but how big is an atom? It's kind of hard to tell. We can't see them with our eyes. So what if I offered you 1 atom of gold for every second since the Big Bang? Do you think that you would be rich? So take a second to think about that. I mean, there's a bazillion seconds between the Big Bang to now, and if every one of those seconds was an atom, would it add up to enough gold so that maybe you wouldn't, you could retire early? Well, unfortunately, not really. Even though that's a ton of atoms, atoms are really, really small, and those amount of atoms would only really add up to a speck of gold weighing about 0.14 milligrams and only worth 0.21 cents, not even worth 1 penny. So atoms are really, really tiny. So we're going to continue our discussion of atoms and other types of matter. So by the end of this video, you should be able to define and tell the difference between the states of matter, mainly solid, liquid, gas, as well as tell the difference between the types of matter, mainly atoms, compounds, molecules, mixtures, and pure substances. So let's talk a little bit more about matter. Well, we know that matter has mass and occupies space. That's basically how we define matter. So it has mass and volume, basically. So some examples would be chocolate milk, Thanksgiving turkey, or stars. All of those things are matter. Basically, everything is matter. So we've already talked about how atoms are really tiny, and atoms compose matter. So in order to see an atom, we use what's called a scanning tunneling microscope because atoms are so small. And basically, we're using ultra-high magnification, and under this ultra-high magnification, all objects appear similar, so we can kind of see atoms. We're going down to that small of a magnification. And so what this does is it's this fancy microscope, and the tip of the microscope is about the size of an atom. And so it can tell differences within the surface depending on what it's composed of. So here's a picture of what we would see with a scanning tunneling microscope. So we can't really see atoms specifically, but we can see the result of what an atom does to a surface. Okay, let's talk a little bit more about atoms. So we know that not all atoms are alike. Matter is composed from approximately 100 different types of atoms, and so we call each of these different types of atoms elements, and this is what we find on the periodic table. Okay, so here's a picture. We've got our standard protons and neutrons in the nucleus and the electrons on the outside of the atom. So atoms compose matter, and there are 3 states of matter that we're going to talk about mainly. So solids are a fixed shape and volume. So this cube here, the particles aren't going to move very much. It's pretty much set. Liquids have a definite volume, but they take the shape of whatever container they're put into. So if you measured out 100 milliliters using a beaker, which is shown here, if you put that liquid into, let's say, a flask, which is similar to what's shown for the gas, it will still read 100 milliliters, but obviously the shape is going to be different. Gases have no fixed volume or shape. They will uniformly fill whatever space they occupy, so whatever container they're in. So that would probably mean that their particles are going to move around a little more quickly than, let's say, those in a solid, or at least move around more independently. Okay, so here's our first check for understanding. Come up with your own analogy to describe the 3 states of matter. Remember, an analogy just has the same function, but is a different object. So, like, for example, if I was talking about the cell, I would say the nucleus of a cell controls the cell, and I would maybe say the analogy to that would be the principal's office controlling a school. Okay, include a verbal description of your analogy as well as a drawing. Okay, so once you've completed that check for understanding, let's go on to types of matter. So the first type of matter we're going to talk about are elements. Elements contain only 1 type of atom, and they can also contain molecules, but still only 1 type of atom. So this is what we would call an element, and I would actually also call it an atom because it's just 1 single atom. Okay, this picture showing 2 atoms put together is also technically still an element because it still only contains 1 type of atom. They just happen to be bonded together. But because now we have more than 1 atom, we're also going to call this a molecule. So both of these are elements, but only this one is a molecule. So let's talk a little bit more about that difference. Okay, well, we've talked about how we bonded these two atoms together. So we can make substances by bonding atoms together in very specific ways. So a molecule, like we already talked about, is at least two atoms bonded together. But a compound is also two atoms, but they must be different. So a molecule can be at least two atoms as long as they're all the same, whereas a compound, you must have at least two different atoms in your substance. So let's look at an example of that. So here we have three atoms put together, so we're meeting the requirement of at least two, but because they're all the same, this would be a molecule. And here, again, we have more than two atoms, or two or more, but because we have different ones, this is a compound. This is actually the structural formula for water. Okay, so let's talk a little bit more about the difference between elements and compounds. The properties of a compound are usually different from the elements that make it up. So for example, we have sodium. Sodium is an element. In its regular form, it exists as a very shiny, soft metal that violently reacts when it's put in water. So if you're ever storing sodium, it gets stored in oil. And that's probably why we don't have it here, because it can violently react with water, which makes it dangerous. Chlorine in its natural state is in a gas form. It's kind of a green gas, and it can be very poisonous. But if you react these two elements together to form a compound, you form sodium chloride, which is just table salt, which you probably eat a little bit of at least every day. So we have very different properties of elements versus the compound. The next state of matter type of matter we're going to talk about are pure substances. Pure substances are always the same composition. So this would encompass elements, compounds, and molecules. And it encompasses these things because they are always the same composition. Elements would be a single, atom or a group of the same type of atom. Compounds are going to be two different atoms put together, but always in that same ratio. Mixtures are where things get a little bit different. So a mixture is a material of variable composition that contains two or more substances. So the big key difference here is that we said, where's my pen? Variable. Pure substances, the composition is always the same no matter what. You get a glass of water from here and you get a glass of water from Kentucky, and if it's H2O. Okay, but mixtures are variable. So some examples of a mixture would be wood, soda, coffee, air. The mixture of air is always different. So the composition of the mixtures varies, but the composition of substances is always the same. So for an example of a mixture would be an alloy. This is a mixture of metals. So white gold is a mixture of different metals, one of them being gold. Steel is another example of an alloy, or brass. Mixtures can be separated into pure substances by certain processes that we're going to talk about in section 2. And so we can either separate our mixtures into elements and or compounds. There are two main types of mixtures, homogeneous and heterogeneous. So the prefix homo means the same, and so another word for a homogeneous mixture is a solution. This type of mixture would look the same throughout. You wouldn't be able to pick out different parts. So some examples would be air or the alloy brass, which is a mixture of copper and zinc. You can't see parts of copper and zinc. It all looks the same color. Heterogeneous mixture is not the same throughout. Hetero means different. And so an example of this would be trail mix. You can pick out the peanuts from the raisins, from the M&Ms, from whatever else is in your trail mix. Okay, so this takes us to our second check for understanding. What I'd like you to do is create a graphic organizer that includes all types of matter discussed in the video, and include an explanation of your graphic organizer as well. So make sure to include elements, compounds, pure substances, mixtures, homogeneous and heterogeneous mixtures. All right, have a good day.